Great. So good afternoon, everybody, and welcome to this month's TNZ panel discussion focusing on carbon dioxide removal technologies. So as you might remember, last month we have been talking a little bit about TAC, and we heard about a demonstrator, so a project that was actually looking into the feasibility of direct air capture in the UK. And for this session, we thought about bringing you a little bit the experience of Biochar. So the techno-economic aspects of this technology, how it works as a carbon dioxide removal technology, the opportunities and the challenges, and the potential integration in the carbon removal market. So we assemble a very nice lineup of speakers. We are going to hear from Ondřej Mašek, who is a reader in energy system at the University of Edinburgh and has an extensive background in biochar. Then we're going to hear from Merritt Dailey, who is a PhD candidate at the Arizona State University. She has extensive expertise in direct air capture, so she's going to bring a little bit of a almost opposite view of a technical removal option, so direct air capture. And then lastly, we're going to hear from Meera Atreya, who's a senior advisor at Carbon Direct. And she's going to talk us through a little bit the latest developments in the market space, what is happening in the US, and how we could actually think about integrating this technology in the market. Meera is actually on her way to the airport, so she might join a bit late. But just as a reminder, we are going to hear for about 30 minutes of a contribution from the speakers, and then I will open the floor for the discussion. As always, you are welcome to post your question on the chat, and I will bring it up and then direct it to the speakers. Otherwise, you can also raise your hand and speak directly in the meeting. And so without further ado, I'll leave the floor to Ondřej, and I'm very looking forward to the discussion today.
Okay, thank you very much. So I will share my slides. I prepared a few slides just to accompany my introduction of the topic of biochar. So give me just a second while I'm finding it here. There we go. So hopefully you can now see my slides. Excellent. So I can't see anyone now. So if there are any questions, I'll probably take them later. Well, thank you very much for the invitation and the opportunity to present here today. My name is Ondřej Mašek, and I'm working at the University of Edinburgh. I'm a co-founder of the UK Biochar Research Centre that's now been around for about 12 years or so. So we've had a lot of research done, and we have a lot of expertise on biochar, or a lot of different aspects of biochar. What I wanted to do in this 10-minute introduction or so is, for those who are perhaps less familiar with the concept of biochar, to really provide some general background so that we can then open up the floor for discussions and questions on any specifics later on. So I'm not going to go into great detail on any of those things. It's really just to provide some general overview. So starting with the concept of biochar and how it actually removes carbon, because sometimes I come across people who misunderstand the way that biochar works. So the way that the biochar captures or stores carbon is by fixing the carbon that's present in biomass that was initially removed during photosynthesis from the atmosphere, and we convert it into a form of carbon that's much more difficult to degrade. So in a natural cycle, as you can see here, the carbon that's in the biomass ends up in the soil or goes directly into the atmosphere during decomposition. And within few years, depending on the climate and the conditions, most of this carbon is returned to the atmosphere, either in form of CO2 or worse, methane. Now, what biochar aims to do is to change this carbon into a much more resistant form that can be applied to soil, it can be applied to construction material, it can be used for other things. The main point is that that material should not decompose readily and return carbon back into the atmosphere. And we are talking about sort of time scales of hundreds of years or thousands of years for that. So that's just to clarify the concept of biochar and how it works. So it's not the solid material actually capturing CO2 itself, it's the carbon that was in the biomass that we distilled really into a solid form that's difficult to degrade. So a few just pictures here of our research on biochar production, because as I understand, most of the audience here is from chemical engineering, so this will be probably quite close to your heart. So we have a range of facilities from a very small sort of milligram scale facilities for biochar production and testing, all the way to a pilot scale facility where we can process up to about 50 kilos per hour of biomass, so producing tens of kilos per hour of biochar. And that accompanied by extensive range of analytical facilities, which then help us to better understand the properties of biochar. Because on the sort of first look of it, it all might look like charcoal, but the physical chemical properties vary considerably depending on the way of production, depending on the processing conditions, depending on the type of material we work with, and so on. And I'll mention that a little bit later as well. So here we have a slide that lists some of the key areas of applications of biochar, and also some of the key characteristics or sort of types of characteristics of biochar that we are interested in and that help us to match a particular type of biochar to a particular application. Now you might note here in all these applications that one thing that's in common is the fact that the carbon is still retained in its solid form. It is not converted into gas, so we are not burning the biochar at any point, releasing carbon dioxide. So whether it's a soil application where the carbon ends up in the soil, it may be changing the physical properties of the soil, it may be helping the plants in terms of management of nutrients and so on. It can be in construction materials, it can be in various sensors and catalyst supports, it can be an additive in polymers and so on. But in all these cases, the carbon is still present in a solid form. That's the key point here. If there is an application that requires the carbon to be converted into CO2, then that would not really count as a carbon sequestration option, unless of course that CO2 is captured. So a few examples here from an ongoing project we are participating in. It's a EU-funded project called Biochar, and we are looking at 3 specific applications here. One is in agriculture, mainly looking at the use of biochar in polymers that are used in agriculture. And these are biodegradable polymers, so the biochar eventually does end up in the soil after it has fulfilled its function in the protective covers. The second one is in wearable electronics. This is for sensors that are in contact with skin for measuring all sort of biometric signals. And finally, here is also in construction, so specifically in 3D printed sort of construction products and elements of different structures. Now, in terms of production of biochar, there are many things we can use to tune the properties of the biochar. So again, I really would like to dispel possibly a notion that any sort of black biochar, charcoal looking like stuff is biochar, and it's all the same. Well, it isn't. So we can, starting from the biomass that we use, we can work with woody biomass and forest residues. We can work with agricultural residues, so straw, husks, and so on. It can be algae, can be organic residues, like and also sludges. We can then do various pretreatments, so we can process the biomass physically, chemically, or combination of both. We then have a lot of options how we can change the pyrolysis process itself. So what temperature we choose, how fast we heat things, how long do we keep them at the temperature, how much do we allow the solids to interact with the vapors that are produced, and so on. Many options there. Post-treatment as well, so we can do a lot of things with the biochar that we produced. Again, it can be physical, can be chemical in nature, just to allow, and that allows us to modify the properties of the biochar. And finally, we can also use various additives or dopants, either in the biochar production process or afterwards, after production. And again, that can help us considerably to tune it to a specific application. So a few examples here, so how this can fit into sort of bigger systems. So here's an example of a first generation biorefinery, whether that's a corn ethanol, it could be a bagasse, or it can also be from whiskey production. So it's a biorefinery of sorts as well. And all of these produce quite large volumes of biomass that can be used. At the moment, typically it's used just for providing heat internally for the processes. Often that's not very efficient, so much better use could be to actually pyrolyze this, convert it into biochar, into liquids that have further uses as well, and heat as well that can still be used in the process. Similar thing for second generation biorefineries. So this is using lignocellulosic material, and this process typically leaves behind quite large volumes of lignin. Depending on the type of refinery, there are different types of lignin that come even from the same biomass, and these are listed here. And these are actually really excellent starting materials for biochar production. They yield a lot of biochar, so we can have quite efficient carbon sequestration in that form. And also they yield for the liquid products rich in phenolic compounds that have subsequent applications as well. And the third generation biorefinery, so relying on algae, whether it's microalgae or macroalgae, these are used already extensively for production of various chemicals, food additives, pharmaceuticals, and so on. But these extraction processes, again, leave behind a large amount of residues that can be used for other applications, including biochar. One of the reasons why biochar application may be beneficial here is, beside the carbon storage, also the fact that these materials contain quite a lot of nutrients that, if the biochar is then used in the soil, return those nutrients to actual sort of use. Here's a list, sort of wider list of different type of applications of biochar in different sectors and areas. What I wanted to show here is that beside the individual applications, so we can produce a biochar with one particular application in mind, we can actually also look at sequences of applications. So where we use biochar first for one thing, then another, and so on. There can be 2 steps, 3 steps, even 4 steps, and so on. So there are just a few examples of those here. And I'll skip the rest of the animation. And that's something we have worked on in another EU project that's now finished. And finally, I just wanted to show some of the economics of biochar production. This is a study from 2011 by colleague Dr. Simon Sheckley. And this looked at the potential for biochar production in terms of the volumes or how much CO2 can be sequestered, at what cost, using what different materials. And one thing I think that's interesting here and that really sets biochar apart from most other carbon removal technologies is the fact that you can actually produce carbon at negative, or remove carbon at negative cost. And that's on the left side of the graph here. So if we use waste materials where normally there is a gate fee charged for disposal of these materials, if you can convert this successfully into a usable biochar, you actually get paid for removing the carbon, so you don't have to charge anyone for the carbon. Of course, if there is a price for carbon, then the economics works even better. Now, as we move towards the right here, then we get sort of, let's say, nicer materials to work with. So it could be imported wood chips or wood pellets. It can be sawmill residues and so on. But then, of course, the price goes higher. So in terms of the cost of per ton of CO2 removed gets higher because we have to pay more for the starting material. And that's all as an introduction from me, and I look forward to questions in the second half of the session.
Great. Thank you, Ondřej. I was actually not aware of all the different pathways that are associated with biochar, because I guess also, like from a scientific point of view, I mean, the one that we mainly hear is kind of like the pyrolysis of biomass and then the biochar production and the distribution into the soil. So it was very, very interesting to hear that. Yeah, but I guess we're going to discuss this very soon. Okay. Great. So thanks a lot. And we're going to hear from Meera. So completely different point of view, I guess, because we're going to hear mainly from Doug and the main, the recent developments, the opportunities that direct capture can bring, and the challenges as well. So Meera, the floor is for you.
Thanks. And welcome, Meera. It seems like you're joining us again. Hello. Hi. So it sounds like this is a group that knows a good amount about DAC already, which is nice. I think broadly I can talk about the sort of path to a lower cost for DAC. So there's a lot that can be done here. I would say that I've seen lately some really, really clever designs for how to sort of manage or optimize process engineering. So that historically has been something that's somewhat overlooked. I've seen a lot of emphasis historically on sorbents, coming up with some great sorbent that performs extremely well. Lately, more and more companies that I see coming online have really clever processes. So I think there's a lot of room in process engineering to drive down costs. Obviously, I'm sure everyone has heard about how modularity is a huge opportunity in terms of driving down costs. I think that's also true, but to me, it's not clear yet that huge scale, something like, a process like carbon engineering, which is not particularly modular and actually scales very well and will become more cheap with scale, that I think has been somewhat written out, and I don't think that's completely fair. I think there's a lot of room for huge systems like carbon engineering to come down the cost curve quickly. If there's one thing that I impart to you all today, usually I say the reason that we even talk about DAC is that it can offer permanent storage. Sounds like you know that. So in terms of costs, the one thing I would impart is that DAC has not really been built. There's, Orca in Iceland pulling out some tonnage, but it's never really been implemented. And so generally learning by doing leads to pretty rapid cost reduction. So I think in the next 5 to 10 years, when some of these plants get built and are put online, we will see pretty marked price decreases. I don't know how familiar people are with US politics, but it seems like people in the UK are fairly familiar. But in terms of DAC, the Department of Energy just allotted $3.5 billion. So in the past 3 years, there was about $100 million going to DAC research. This year, it has ramped up to $3.5 billion for regional DAC hubs. And so the US government is putting a lot of money into actually deploying DAC units. And everyone keeps wondering, what will the learning rate be? Will it be like solar? I see people comparing this all the time. Who knows? That's a big question. But actually building the units is what's going to really drive down the costs, in my opinion. I've also seen some really, really clever proposals integrating things like artificial intelligence and machine learning into DAC designs. I don't know what I'm allowed to share, probably not much more than that, because some of those proposals are not yet published. But whatever I can, if people want to hear more about that, I'm happy to drill in and share a bit more. I think I'll keep it at that and just be here for questions. If there's specific questions, I'm happy to field them now. Otherwise, I'm going to turn the field over to Meera, who I think is going to talk to us more broadly about the voluntary carbon market.
Super, thank you.
To you.
Can you hear me okay?
Yes.
Okay, perfect. I'm going to share my screen. I have a few slides. I'll talk exactly as Merritt said, more broadly about the carbon market and give a brief introduction to what we do at Carbon Direct. Just bear with me a moment, and apologies for the delay. It's been a bit of a travel zoo today. I'm in transit. Let's see in that window, just 1 second. Apologies, Teams does not play nicely on my computer. Just bear with me a second. Let me know if this is sharing the screen.
It's loading.
Okay. You can see slides or?
We just see loading, so I guess it's going to come up soon.
Success?
Yes.
Okay, perfect. Thank you. I'll try and be quick. So very briefly, let me just tell you about the organization that I work for. So my name is Meera Atreya. I am a senior science advisor for Carbon Direct, and I'm based here in the UK. And I'm leading our London office and our European presence. So briefly, we help clients manage their carbon emissions. So this is about leading with the science. We're a science-first organization with a global team. Like I said, I'm in the UK office. We're headquartered in New York. And we support clients in reduction, removal, and utilization of greenhouse gases through scientific advisory, helping scaling high-quality carbon removal supply, and then also software tools to support our clients with making their net zero emissions goals possible. We are primarily made up of scientists, myself included. We have a science team of 40 plus members, many of whom actually maintain academic affiliations and work with us part-time. So these are researchers across all areas of carbon removal. And we are all going towards the same goal of how do we do carbon management in a way that is really grounded in the science. A couple of very brief examples of work that we've done. We support Microsoft in reaching their carbon negative by 2030 goals and have published with them criteria for high quality carbon removal. One of the major things we do as an organization is deep scientific diligence on carbon removal projects. So we've helped them review and make sense of the voluntary carbon market, which I'll speak more about in a moment. And I've also supported a number of other companies and industries looking to decarbonize and manage their carbon emissions. So as you'll well be aware with this audience, we have a number of critical roles for carbon removal. We need to both accelerate our near-term mitigation, and carbon removal can help accelerate that. We then need to counterbalance any residual emissions we have at net zero, and after mid-century, we need to actively reach net negative. Unfortunately, we are so far from the scale that is required to do this. This industry is exciting, but nascent. And we are, if you take kind of the IPCC estimate of how many tons of carbon must be pulled out of the atmosphere annually by mid-century, we're looking at 10 billion tons of CO2 per year. And right now we are orders of magnitude beneath that, and that would require the kind of growth of roughly 34% annual growth for the next 28 years, every year. So this is building the oil and gas industry twice the size in reverse, and we have less than 3 decades to do it. So it's a big challenge. What we found with the voluntary carbon market specifically is that there's more and more demand to do this and to help scale carbon abatement and carbon removal, but unfortunately, many of the projects that we've looked at doing our scientific diligence we've found to be of low quality. And so their environmental robustness is questionable, often due to flawed methodologies. And while there are a number of certifiers out there, it doesn't guarantee project quality. So we sort of consider this a quality floor rather than sufficient to ensure that the carbon removal that companies are purchasing on the voluntary market are actually meeting the climate goal. And it's very important, of course, that happens for 2 reasons. One, so that the buyer gets what they're paying for, and that if they think they are putting $1 towards carbon management, that it actually is doing that. And then, of course, the other loser, if this isn't real, is the climate. And if we are really trying to move the needle here and deal with all of the emissions we've emitted so far and the vast emissions we continue to let into the atmosphere every year, this needs to be real. And we have to have confidence in this market in order for it to succeed. So we need an intervention on integrity. To do this, we've developed principles for high quality carbon removal. And as I've mentioned, we've published this with Microsoft. This covers a number of different criteria. So additionality and baseline. So this is making sure a carbon project that claims to have an additional climate benefit is actually doing something in addition to what would have happened otherwise, or the counterfactual. Looking at the carbon accounting in great detail and understanding for each of those projects, what does the life cycle analysis look like for carbon? And do these projects, are they doing harm to the ecosystems and the communities that they're around, or hopefully pursuing benefits? How is environmental justice considered in these projects. And then, of course, and one of the things I know this talk is about biochar, durability is a very interesting point on that too. If we have an organization that's emitting 1 ton into the atmosphere for millennia, then we have to be able to think about how do we neutralize that. And 1 year or 10 year or 50 years, that's not equivalent to a permanent emission. So we have to really think about the durability there. And then leakage, which is if you as an example, say we might protect a forest here, well, maybe I'm going to cut down a forest over there. So there are these different principles that we look at for high quality removal when we do our scientific diligence to help buyers find high quality projects. Unfortunately, with the current market, only 8% of the projects that we've done our scientific diligence on have actually met our quality expectations. So this really highlights the need that we need an intervention here to raise the bar on quality. About creating robust markets, just in case anyone is not clear, we have 2 types of carbon markets. Here, we focus a lot on the voluntary carbon market, and I'll speak about that more, but there's of course also the compliance carbon market, which those of us in Europe will be well familiar with, in a sort of cap and trade system, which is regulated, and the voluntary carbon market is not regulated and is completely voluntary, and that purchasers can, purchase it for their own reasons, maybe for their net zero communications or their goals, and then decide to retire or not retire and sell their credits. Importantly here, carbon dioxide removal is not common in either of these markets at the moment. In order for us to actually scale this, we have a couple of different challenges. So I've sort of bucketed these into 3. So first is that the credits that are out there are of poor quality, as I've mentioned, and there's a lack of consensus on what is the right accounting method. And of course, this differs a lot based on the type of project. A second challenge is that there are certification schemes that are not robust, and the actual governance of this may not reflect the latest science. And then a third one being that the lack of assurances for scaling high quality supply makes this a challenge. So there are some resolutions that I proposed here about needing to find better monitoring, reporting, and verification, figuring out how we deal with different durabilities, as I've mentioned, developing really science-based standards and certification processes that raise that bar of quality and are trustworthy, and developing a portfolio approach to market participation. So very briefly, kind of a snapshot on the voluntary carbon market, or the VCM today. Most of these credits are avoidance credits. So this means, I'm going to emit, but look, I haven't, and here's a credit for that. But these are really, really tricky to determine, what was going to happen. And there's only less than 5% of the credits that were retired last year were actually for carbon removal, and all of those we would deem in kind of high risk storage when we look at the durability point. We have a lot more information on this on our insights part of our website if you're interested in a longer commentary. So again, this burden of proof of understanding when you do avoided or reduced emissions, you have to identify what is the counterfactual, what would have happened, and that's very difficult to prove. With removed emissions, it's more simple in that way. If you're pulling carbon dioxide out of the atmosphere, when we're fighting 420 parts per million, of course this is not going to happen on its own. So the burden of proof is a bit more straightforward. And unfortunately, we don't have a system of accounting for the differences in the permanence of tons removed. So this is an article in Nature published by Microsoft and our chief scientist, Julio Friedman, looking at the credits in kind of the bio-based storage of estimated years in storage being on the lower end compared to geosphere-based storage. And ultimately, as I've mentioned, a ton of CO2 emitted in the atmosphere can only be really truly offset by a permanent removal. So this begs the question then, how do we account for permanence of nature-based credits? And we have recently published our viewpoint on this, which you can also find on our website about accounting for durability. But there are a couple of ways to think about it. So you can have either what's called vertical stacking, where you have a number of short-term credits that you stack in some multiple to account for or equate to 1 ton of emissions today that will be in the atmosphere permanently. Or you can do sort of a horizontal stacking where you have a short-term credit that is then paired with a very durable or more permanent solution in the future, which is sort of where we've headed as an organization. But there are different ways to think about this, and it's very much an open question. So we need really science-based developments about what the credible solutions are, and the durability point needs to be built into the market more. And we do have markets, commodities markets certainly have different differentiation. For example, like crude oil or refined oil that we could build into this market. So it's definitely possible to do. In terms of what the voluntary carbon market looks like, there are a lot of ecosystem players with multiple competing standards that makes it really quite difficult to kind of sort out. So this is a work in progress, I would say. And we're making that progress. And here are some examples, and also ways that you, the audience, might be able to help about kind of engaging in the new standards, about helping develop better monitoring and verification technologies so we can be confident in the carbon projects that they're actually doing what they're meant to be doing, and bringing technologies to market. So the First Movers Coalition, which the World Economic Forum launched in Davos, Carbon Direct is actually an implementation partner of that, and this is about developing advanced purchase commitments, which can really help scale new technologies so that they have kind of runway and they know someone will be purchasing their credits, and hopefully that will help them get the financing they need and build those things out so that we can reach our 10 billion tons of carbon removal by 2050 that we need in order to reach our climate targets. So very briefly, our kind of summaries from the state of the carbon market that we discussed today are that the demand for CDR credits in the voluntary carbon market is growing very fast, but faster than supply and regulation can keep up. So we have a lot of opportunities, but also challenges with this. We've really struggled with the voluntary carbon market being flush with projects that are of poor quality. So improvements in accounting, in monitoring and verification, in certification and governance is really important and will help raise a quality floor, which will build the trust in the markets and then help it function the way it's envisioned. And then finally, the scientific community needs to actively work on building consensus about what high quality is and how we measure it so that policy can move faster on certification. Thanks very much.
Great, thank you, Meera, and thank you all. So, well, I mean, it was a very interesting and very eye-opening presentation from all of you. And I mean, basically from what I've understood so far, it seems like the main issue with GGR, so with establishing MRV, it's really also having the right amount of data, right? Because, I mean, Ondřej, from what I've heard from also all the biochar pathways that you showed that I was also personally not aware of, because there is not that much scientific evidence, or at least that I'm aware, or there are not that many articles out there that actually also publish techno-economic assessment on all of these pathways. And so my question to Ondřej first is, of all the pathways that you show, which one do you think it's maybe more promising in terms of also technology readiness level? Because I guess some of them are very much at early stage. And then I have a question for Meera, because you mentioned that only 8% of the projects that you assess actually were kind of like following a certain scientific guideline. So do you think this is because they were mainly projects related to more mature options, CDR options, such as afforestation, or because they were related to simpler options? Because I guess another big issue with CDR is that they can have very long supply chain that are very difficult to monitor. And as Ondřej showed, there are many different variables that are playing in. So what it is because these are kind of like more established pathways, such as afforestation, or yeah. So these were my first two questions, and then I will leave it to you, and then I'll look into the chat for seeing what are the.
Okay, so do you want me to start, or Meera, do you want to go first? Or?
Go ahead.
Okay. So the question was about the techno-economic analysis, and so how much do we know about those different options. So, and also sort of where let's say the technology readiness level is. So I would say for basic biochar production, that's pretty much there. I mean, that's not too different from charcoal production that has been around for thousands of years. So we know we can do it. Now, when it comes to the specialized sort of applications of biochar, these are much more recent developments, and there are various reasons for why sort of the things have gone the way they have. If we already had a high price for carbon that pays for the whole process itself and the feedstock and so on, there perhaps would be less driver for looking for additional benefits that biochar can do, but that's not the case. So people are looking at what are the additional benefits that biochar can do, and I think that's actually a good thing, because if we can utilize more than one function of the material, then we should definitely do that, because then we get not just the direct benefit of storing carbon, but also potentially other environmental or other economic advantages of that. In terms of the techno-economics, so there have been some studies done on this, but you are right that there isn't a huge amount on that, and certainly not exploring all those different pathways. So I think there is still a lot of work that needs to be done on that, and that's both from the techno-economic perspective, but also looking at the carbon balances. So what can we achieve, for example, if we use biochar in construction industry as a replacement for certain additives that are used at the moment? What benefit or not can we get from that? And the same for various environmental applications. There can be also quite a lot of uncertainty, because there is a huge amount of literature. I mean, there are thousands and thousands of papers on biochar and its different applications. Some of them better than others, but at the moment it's really quite difficult to distill sort of one single conclusion out of it and say, okay, biochar is really good for this thing or not so good for that thing. That's partly because of the way that those different experiments were done or reported, but also because of the variation of the applications. So even if we just look at application in soil for agriculture, well, it very much depends on the type of soil, the type of crops, the type of climate, and so on. So understandably, there is a huge range of results. So you can have really surprising, excellent results in one setting and really poor results in another one. So you can't just say, yes, biochar is great for agriculture. You always have to look at what you are using it for. So it's always case specific.
And Ondřej, sorry, Meera, just as a follow-up, I guess what you said just apply also for the question that Niall has just posted in the chat, which is how long does biochar actually last once it's integrated in the soil?
Yeah, so again, there isn't a single number we can pull. It depends on the nature of the biochar, and also then there is a question: what do you actually define that is biochar? Because you can, heat biomass to different temperatures and get differently treated biomass. So if you start, let's say, at low temperature, something like 350. You get really just a sort of toasted biomass that won't last much longer in the soil than the original biomass. You can go to the other extreme and heat it to 1500 degrees, where you have very little left behind, but whatever is left behind is very hard to decompose. And then there is anything in between. So yeah, it can be anywhere, sort of from prolonging the natural sort of biomass decomposition from a few years to maybe a few tens of years. And you can push it over all the way to sort of thousands. It's unlikely you will go to sort of geological scales of tens of thousands or hundreds of thousands of years. So I think the thousands or so is about the upper limit.
Okay, Meera, do you want to?
Yes, so I think just to play back your question, make sure I understood it, was the why is it so low? I guess the question of why are not all the projects that we look at kind of meeting that bar. So one thing I just want to clarify is we're certainly not against nature-based projects at all. We have a large forestry team, and we have definitely found high quality carbon removal that falls in that bucket, and it's of course super important to protect natural spaces, and we recognize all of the co-benefits for biodiversity and for communities and ecosystems. So just to make that abundantly clear, but in terms of why things don't meet that bar, a lot of it is that the projects don't often meet the additionality factor, and that can be, usually it's from a carbon accounting perspective, but it can also be from a financial perspective of for the latter, does this project actually need an extra pound of climate finance, in order for it to be competitive. And so maybe something is already economically viable and doesn't actually require that sort of finance. It could also be things like, how do you prove the counterfactual? And again, this is very difficult to do in the kind of nature-based realm, and not that there aren't good projects there again, but it is challenging to understand, for example, with RED projects, was that forest going to be cut down? Like, how do you actually suss out what the counterfactual is? And so I think it's certainly not for lack of trying to do a good job here. I think part of it is that a lot of the credits that we're now seeing are on the older end of the scale, and where we had less scientific understanding at that time, and the protocols and things at that time were not as robust as they are now. And so I think we're starting to see with the different methodologies and protocols more sophistication there, but a lot of the credits that are already existing on the market maybe don't meet our current bar.
Understood. Thank you. So I see some hand raised. So one from Mai, do you want to come in? And
Yep. So I think my questions relate to some of the things, the points that Merritt made around sort of direct air capture. And she mentioned something about these direct air capture hubs that the US has proposed. And I guess my thinking, or my question, is kind of around what's the sort of criteria, because within the UK and in Europe, we're kind of thinking about sort of industrial cluster hubs, and some of the hubs are including sort of GGR or CO2 removal technologies within these industrial cluster hubs because you could share infrastructure. But what I'm getting the feeling of the labeling with the US is this kind of just a direct air capture hub, as in they're building dedicated infrastructure just for direct air capture, and they're not co-locating it with industry, for instance, as they are in Europe and in the UK?
Yeah, that's a really good question. So I think your instinct is dead right. They're not necessarily co-locating it with industry. How the proposals are looking now, they bucket the US into regions. So there's like broadly Southwest. So where Arizona is, for example, if Arizona State University or really any entity wanted to bid forth, they would say, okay, we can handle the removal. We have this technology. We're going to cover the removal part. And then a different provider will say, we're going to handle the storage. And so the US is sort of in parallel going to be testing all these different technologies, from storage to direct air capture, at all different parts of the world, or not the world, the US. So there's going to be a different, a very different climate in Washington State versus Arizona, and that will require different technology. And that's one of the really cool things about the DAC hub idea, is that you're going to kind of supercharge testing along a huge variety of lines with a ton of different people, throw a ton of money at the problem, and see what comes out of it, as the US likes to do.
Very cool. Thanks, Meera. And I guess with the storage side, like, are they going to stay away from enhanced oil recovery, or is it just still unclear at this point?
It's unclear. I would love to say I'm very confident that no regulatory capture will happen and that EOR will not happen for sure. But I think it's very possible that someone will eke by with some EOR or some other CCU and call it climate negative. As Meera was saying, we've seen a lot of very dodgy accounting that people are trying to get away with. And I bet, you've seen that yourselves in your own work.
Great. Fantastic. Thanks.
Okay, thank you, Mike. So I see other hands. So one is from Agustin. Agustin, do you want to ask your question? Because I don't see it in the chat. So you want
yeah,
to...
sure. Can you hear me well?
Yes, you can.
Yeah. Thank you very much for this interesting interaction between three different backgrounds. I had more biochar question. So it's interesting how complex biochar could be, actually, because it has different co-benefits apart from that of sequestering carbon. And I think one of each is also, so correct me if I'm wrong, but is also reducing emissions from CO2 and nitrous oxide emissions from fertilizers. So is it a big part of a big percentage of compared to the removal to the actual removal or not? And the other question is on the graph with negative biochar prices, where does the revenue come from? Is it by selling the syngas that it produces, or is it another technology from another pathway that I've not accounted for?
Okay.
Thank you.
Yeah, so thank you for the question. So for the first part, so yes, in some applications, biochar can result in the reduction of emissions of greenhouse gases from soil, and it can be nitrous oxide, can be methane. So an example would be, for example, rice paddies. And then that can actually constitute quite a considerable sort of additional benefit because of the potency of these greenhouse gases. But again, this is not something that can be generally stated that biochar application will always do that. It's very specific again to the nature of the soil and the climate. So yes, the possibility is certainly there, but how to sort of work that into a proper accounting, that needs to be done really carefully, so that you don't just sort of as a blanket assume that this is always the case. For the second part, so the graph on the left side where there were the negative costs, so this is actually because you get paid for taking the material away from people. So it's instead of sending it to a landfill where you would have to pay £100, £200 per ton of that material, you can still charge the same as a facility that produces biochar, and then you turn this into biochar rather than just putting it in the landfill. So that's where the revenue comes from. Okay, so it's like a waste management process. Now, I didn't have the chance to go into detail there. Of course, you have to be very careful because well, you get more money for the nastier the material is that you are dealing with. So you have to be very careful what you are working with. You don't want to produce biochar from something that's toxic and remains toxic after you convert it into biochar. So there are some exceptions where something that is problematic as a feedstock actually is nice and safe after processing, but that's not true for everything. Okay, I hope that clarifies that.
Thank you.
Thank you, Ondřej. And actually, there was a follow-up question again for you with regard to what do you think is actually the most promising option, since you showed that kind of like range. So especially from a carbon removal perspective, so what do you think is actually what we're going to see?
Yeah. Well, so in terms of the volume, I think it's soil applications where there is the largest potential for storing the biggest amount of carbon, just simply because there is such a large sink that not only can accept biochar, but actually can benefit from the biochar application to it, because a lot of our soils are depleted of carbon because of the intensive management. So adding the carbon in form of biochar actually helps them. So it's not just we are putting there something we want to store, it actually can help. So in terms of volume and how much carbon we can store, that would be the number one application. In terms of sort of immediate economic benefits, that's probably not where that will be. There are a number of niche applications. We have a startup company from my group that's developing biochar as an additive to anaerobic digestion. And they now already have first commercial partners that are looking sort of actually investing into that, because you can have a fairly quick sort of profit from using that biochar, because you increase the methane production potential of your process. But again, that on a global scale is not going to make a major contribution to carbon storage. This is really something that can help to get biochar as a technology off the ground now, because it does not need to wait for biochar to be accepted in carbon trading and so on and so on. It's something where you actually get paid for the other benefits, and the storage of carbon is a secondary benefit.
Okay, great. Great. So before Niall, I might have also a question for Meera again. So Meera, you were mentioning about the co-benefit as well, so which of course are very important, especially when it comes to natural-based solution. So I was thinking, are you also starting to consider potential biodiversity impact, so kind of like benefits for biodiversity, and have someone or anyone thought about how to account for that? Because I know it's extremely challenging and difficult to account for biodiversity impacts.
Yeah, so I'm glad you bring that up, because at the moment what we've been talking about is purely a carbon accounting point, and exactly to your point, there are so many benefits that unfortunately we don't have markets for, and we don't have a way of really valuing properly. So I wholeheartedly agree that I think there's a gap there. And if we're talking about purely on an accounting level for carbon, and we have an emission that's in the atmosphere for millennia, then in order to properly account for that, we do need a removal that's equivalent in durability and that length of time. And things like biochar that have a really long lifetime of carbon storage and are durable in that way are really helpful with that. Where we have shorter term durability, things that may be in less in kind of a hybrid sphere and more in the pure nature sphere, I think we need ways of valuing that are not just tied to carbon, because there are so many. I think no one wants to see a world without forests, of course, and there are many other benefits there that don't have the right marketplace economic drivers protecting them. And I think we're not going to get there alone just on the carbon benefit, because again, accounting wise, you're not actually able to in all cases have a pure long-standing removal. There are of course exceptions to this, and there are forests that have been around for a very, very long time, and I hope that continues, but we really need other ways of valuing those co-benefits. So I would throw that back to the group as something we need to improve on and work on.
Yes, great. Niall, I see you have your hand raised. Do you want to come up? And great.
Thank you. Can you hear me? Thanks, Piera. So my question is kind of at Mašek and Meera, I think. And I think it goes something like, Mašek, per unit of farmland or per unit area, right? One can only deploy so much carbon removal, so much biochar, leading to a relatively modest amount of carbon removal per unit area or per farm or per landowner. And sort of thinking about this relative to the kinds of scale of a global carbon removal sort of targets, and then the Meera, the sort of the ticket size, I mean, the number of tons that you guys will ultimately want to be buying. And so I'm just wondering if there isn't some kind of disconnect between the scale of carbon removal. So basically, is there a disconnect between the scale of carbon removal that can be offered by individual landowners via biochar pathways, and does that pose a problem for markets, Meera? And Mašek, I think I heard, or I think I understood from your remarks, that the primary benefit of biochar to the landowner is more the sort of the soil amendment and the improving the soil productivity, with carbon removal being somewhat secondary. So that if I heard you right, who do you imagine would seek to retain ownership of the carbon removal service, and how would that entity interact with the sort of the carbon direct marketplace piece? If that's not too confused of a question, I'd love your views. Thank you.
Okay, thank you. That's a very good question. So I'll try to unpick it a little bit. So first, regarding the scale. So there are two ways to look at it. So when per unit of area, there is only so much biomass you can produce. So if you are looking at producing biochar from the biomass that's produced on that specific area, there is only very limited amount of biochar you will be able to apply to area.
Sorry, just a quick one. So I was talking about, so this really goes to my question, right? Who owns the carbon removal service, right? Is it the person who produces the biochar, or is it the person who puts the biochar into the land? Is it the landowner? Or are those two people the same thing? Thank you.
Yeah, so that's, very good question. And I do not have an answer to that, because both are possible. So it really is then depends on the arrangement between the processor, who really what they do, they stabilize the carbon that was in the biomass in a form that does not decompose. But yes, that needs to then be applied somewhere. And how you proportion that between the processor or the producer of the biochar and the person who actually applies in the land where the biochar then gets stored, that really still needs to be defined, because either of those options is possible. It could be the company that does the conversion, because you could say they are locking the carbon, but it could also be the person that actually applies it and keeps it there stored for hundreds of years. So I'm afraid I can't give you a single answer. It's that one or that one. It could be either of them. But I would like to actually hear from Meera as well what she thinks about that.
Yeah, so it's an interesting point, this one, about who owns it. And we also have to be careful with that, about being clear that there isn't a double counting, and there would be a financial incentive to do so. So again, comes back to our needing to have really good and robust methodologies and accounting for this. I think your point, Niall, about how do you scale something that's ultimately smallholders, individual farmers and landowners, to something that needs to be gigatons, is an interesting challenge. And maybe that's, I'm just going on a limb here, but maybe that's a community-based opportunity where perhaps there's a collective, and I imagine that folks like this would already have networks in place that they could kind of join together in terms of sharing methodologies and protocols and certification, and then kind of bring those small number of tons into a bigger conglomerate.
I think Piera will shoot me if I ask him more questions, so thank you very much.
If I can just come back just on one more point, so what I mentioned earlier was that there is a disconnect about the amount of carbon in the biomass that you can produce on that land. So I think more realistic is that the farmers will be applying much more carbon on their land than what they actually would produce there in a year. But then you would not necessarily do an annual application, so you might not be applying to the same tonnages of biochar every single year. You might do that every 2, 3, 4, 5 years or so. So again, that's just perhaps adds a bit more to the complexity of it. So you will be actually importing carbon from someone else that you are then storing on your land.
Okay, great. Well, I mean, unfortunately, I have to close off this very, very, very interesting discussion. I really enjoyed it. So thank you very much to all speakers. I just want to quickly announce the next Friday seminar. We're going to hear from PhD student Jun Hee Kui. She's going to present her PhD work. I'm sorry I cannot read the title, but there are too many acronyms and I'm not an IT speaker. I'm going to make a mess. So I'm going to put it, I hope Pavna is going to promote it with the right title. So if you can all join me for a round of applause, many thanks to all of you. Really was a very interesting discussion. And so I see that no one is uploading. Many thanks. Okay, they're gonna put it online. No, but I really enjoyed it, and I'm sure all of us has enjoyed it. So thank you again, and Ondřej, well, enjoy your holidays, and I hope to see you, Merritt and Meera, soon, and enjoy your weekends. Thank you.
Thanks very much.
Thank you. Bye.
Thank you.
Thank you.